Hey guys, welcome to your lesson on combining like terms. Before we dive into some content, let's go ahead and look at some vocabulary. So, an expression containing variables, numbers, and operation symbols is called an algebraic expression. Please keep in mind that for it to be algebraic, it needs to have a variable. Okay, an expression does not contain an equal sign. So if we take a look at the example that I have here, which is 5x plus 7y minus 3, there is no equal sign, which makes this an expression. There are different parts of an algebraic expression, so let's go ahead and unpack that. We have coefficients, we have variables, constants, and terms. There are four parts there. Our variables are the letters in our expression. In my example, 5x plus 7y minus 3, I have x and y as my variables. I have two different variables. My coefficients are the numbers in front of those variables. So in front of x, I have 5, and in front of y, I have 7. So those are my two coefficients, 5 and 7. My constants are the plain numbers. Those are numbers that are by themselves. That means there is no variable next to that term. And here we have -3. Please keep in mind that when you're identifying your constant, it's very important that you also identify the sign in front of your constant. This is not just 3, this is -3. Okay? Your terms are separated by pluses and minuses, and they can be a term with a variable or without. So in this particular example of 5x plus 7y minus 3, there are three terms. Notice how I basically wrote this expression without the plus and without the minus sign. 5x, 7y, and 3. Those are the three terms. Okay, so let's go over how to identify whether or not two terms are like terms. In the first example, I wrote the yes. They are like terms because they have the same variable, okay? 4 has an x and 3 has an x, so we can combine that. So take a look at example 2. I have 4x and 6y. Do you guys think those are like terms? All right, no. You guys can understand that pretty quickly. No, because they have different variables. They have different letters, so we can't combine them. What about 9xy and 3x? Are they like terms? No, they're not, because the 3x is missing the y. So even though both of these terms have an x, the 9xy has an extra letter, okay? What about example 4? They have the same variable of x, and then now we have exponents. This is x to the second power, which we can say x squared, and then we have x to the third power, which we can say x cubed. They are not like terms. They're different exponents, so we cannot combine them. All right, example 5, 4x squared y to the fourth power and 3x squared y to the fourth power. Same variables and same exponents. Yes, they are like terms. And last example here, I have x and 7x. Yes, they are like terms. They have the same variable. Okay, so what's the biggest takeaway here? You can basically only combine like terms if they have the same variable, which means they have the same letter, and the same exponent. So take a look at this example here. We can combine 3x and -7x because they have the same variable. We can also combine 2y squared and 6y squared because they have the same variable and the same exponent. This is an example of unlike terms. The 4x has 1 as an exponent, even though you can't see it. And then the 6x has a 2 as an exponent. So they're not like terms because they have different exponents. Okay? Let's go ahead and look at example 1. They both have the same variable of x, so I'm basically just combining the coefficients. I'm doing -3 plus 6, which gives me +3. So I have 3x as my final answer. Example 2. They have the same letter, the same variable, but do they have the same exponent? No, they don't. So I cannot combine them. They're not like terms because they have different exponents, okay? Example 3. 8m squared plus 5m minus 3m squared plus 6. Okay, let's first look at the first term, 8m squared. Once you identify your first term, you want to scan the rest of your expression, and you want to look for a term that has an m as a variable and 2 as an exponent. And I can tell right away the -3 does. Those seem to be the only like terms in my expression, so when I combine them, I'm combining the coefficients. I'm doing 8 minus 3, which gives me 5. So my final answer is going to be 5m squared plus 5m plus 6. It's my final answer because I can't simplify any further. These are not like terms. All right, example 4. I have 9x minus 10x squared minus 3x plus 5x squared. Let's go ahead and look at the first term. And I like to look at the term with the highest exponent first, because when you write your final answer, your first term has to have the highest power. That's how we write it in standard form. So I went ahead and I identified that. That's negative 10x squared. I'm going to scan the rest of my expression, looking for a term that has x and 2 as an exponent. And that's going to be positive 5x squared. Negative 10 plus 5 will give me negative 5. And then I have 9x that I can combine with the negative 3x. They both have an x, and 9 minus 3 is 6. So this is my final answer, negative 5x squared plus 6x. All right, guys, good luck on your independent practice. You guys got this.